Hi, I'm Paulette, and today I'll be talking about dependent type preserving memory allocation. So as a little bit of motivation, here's my literal face when programming in Coq. Clearly, programming in Coq requires a lot of effort, but it is done because it's so important for software to behave correctly according to some specification. But to execute these programs we spend so much time proving properties about, we need a compiler. Compilers themselves are underspecified incorrect software. While great work has been done in the verified compiler space, this isn't the end of the story for executing a program. In particular, we need to link compiled programs with external, quite likely unverified components. This is where verified compilers fall short in terms of guaranteeing the correct behavior of source programs, because errors can occur due to the linking process. A possible solution to linking errors is type-preserving compilation. To prevent linking errors, one can compile with a type-preserving compiler. Then, before linking, we type check to ensure that the external code does not violate any of the specifications of the compiled program. Towards preventing linking errors using type checking, work has been done to develop a dependent type preserving compiler. This work is about the dependent type preserving memory allocation pass, as the previous two passes have already been done. The main point of interest is the design of the target language that enables the memory allocation pass to be proven type preserving. The memory allocation compiler pass generates a program that explicitly allocates pairs and closures on the heap. This means that every time we see a pair E1, E2 with the following sigma type, we need to convert it to something as follows. First, we malloc some memory according to the types A and B. Then we sequentially assign each element in the allocated memory with the result of compiling E1 and E2. This means our dependently typed target language needs these constructs to allocate and initialize memory, and should enable this translation to be type preserving. The target language developed for this pass is based on the language after closure conversion. We call it the closure converted calculus of constructions with allocation. This language has memory initialization constructs, as well as a dependent pair or sigma type that requires initialization flags on each element, i.e. it's 0 if it's uninitialized or 1 if it is. One interesting note about the target language type system is that we must now have access to the heap. This is because expressions such as pairs might appear in types, and now these expressions appear as locations to the heap. So our judgment now must include psi to represent the heap, which is simply a mapping from locations to pairs and their type. Otherwise, the typing rules for the new constructs in the language are quite straightforward. The allocation and initialization operators are typed as dependent pairs, and the first and second projection rely on certain elements of the pair being allocated. Proving type preservation based on the target language turns out to be quite straightforward. While this work is still in progress, it is a promising step towards a full dependent type preserving compiler. Thank you.